Alright guys, so we're working on our Covalent Bonds worksheet, and we've gone through all these basic concepts as far as what a covalent bond is. How do we calculate subatomic particle numbers in each atom for each element, like electrons, protons, and neutrons. We went through Bohr diagrams, and we kind of quickly discussed Lewis dot diagrams, which we'll do a little more in depth today to complete this worksheet. So we should be here, okay? We're looking at identifying covalent bonds, which we know co means together, and valent is referring to the electrons in the outermost shell for each atom, okay? And so here we have CH4, otherwise known as methane. That means 1 carbon, 4 hydrogens, all bonded together. And so we're going to look at carbon and hydrogen alone, okay? Individually, carbon has 6 electrons, protons, and neutrons. And hydrogen has 1 electron, proton, and 0 neutrons. I know that because when I look here at carbon, I have 6 protons, 6 electrons. 12 minus 6 tells me 6 neutrons. And hydrogen, thanks to Maddie for her notes, has 1 proton, 1 electron. And 1 minus 1 is 0, so 0 neutrons. No neutrons in that nucleus, okay? So with our Bohr diagram, we would say this. We said for carbon, we have 6 protons, 6p, and 6 neutrons. That's in the nucleus. And in the first energy level, it can only hold 2. So we get 1, 2 in that first energy level. And there's 6 total, so we need 4 more going to that next energy level. But we also know the second energy level can hold up to 8, okay? And so I have 2 open spots, on each side. 4 total in that outermost layer, okay? For hydrogen, 1, 1, and 0. So my 1 electron goes around the outside, 1 proton, and 0 neutrons, okay? And so this is a Bohr diagram, but we're going to simplify it, and we're going to put it into Lewis dot diagrams, okay? The Lewis dot diagram takes this concept and it makes it real simple. It basically says, all right, carbon, what we really are concerned with here when it comes to bonding is its valence electrons. It has 4. Done, okay? That's it right there. The 4 representing the 4 outermost electrons in that outer layer, okay? And for hydrogen, we have 1. That's it. Easy peasy, okay? And so what we're really looking at is how do we make this work? So we know that we have 4 hydrogens because the equation CH4 tells us that. So really we have this H, 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 and H. You don't have to do any of this stuff I just did here, okay? But the Lewis dot part, I'm going to put it together and form the molecule, and then we'll kind of run through and finish the rest of them off, okay? So each hydrogen has 1 valence electron, and carbon has 4. It's looking to fill 8, which means that it has 4 open. And if you start to recognize a pattern here, let's see, hydrogens, there's 4 of them, each with 1. Carbon has 4, but it needs 4, and these guys are all going to partner up, okay? And basically what they'll do is this. This hydrogen's going to go here, right? This hydrogen here, 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 and they're all going to share it, okay? So let me make another look at this. I kind of color-coded these, so my carbon would be orange and my hydrogen blue. And this is what you can go ahead and draw here, okay? Your carbon, 1, 2, 3, 4. Here's 1 hydrogen with its 1, another hydrogen with its 1, a third hydrogen with its 1 electron, and the 4th hydrogen with its electron. And here I see hydrogen has 2 valence electrons now because it's sharing with carbon. And that satisfies it because the first energy shell only takes 2 electrons. Same here, here, and here. So all 4 of those hydrogens have their outermost valence electrons filled. And carbon, looking to fill 8, now has its 8. 1, 2, 3, 4, 5, 6, 7, 8. Because it's sharing, that's what happens in covalent bonds, it's sharing electrons with hydrogen, okay? So let's do the following for ammonia, NH3. Okay, we're going to have nitrogen be the red, and we're going to have hydrogen be the blue. Now we just did hydrogen, and we know from this equation we have 3 hydrogens, so we're going to have this. 1, 2, 3. And the nitrogen is red. We have 7 4 electrons, which means we have 2 on our first layer and 5 surrounding it. Okay? And we want 8. So we can quickly pick up on it has 1, 2, 3 that it needs. It's easier for it to gain 3 than it is for it to give away 5, right? We're not gaining or losing. We're looking at sharing, but in either case, it has 3 openings, and we have 3 hydrogens. So our quick math should tell us, okay, nitrogen is going to bond with hydrogen like this. Okay, right here. Oops, you couldn't see me there, could you? So we get this, nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. It's sharing with hydrogens. Hydrogen has 2, hydrogen has 2, and hydrogen has 2. And those are all satisfied. You're the man, Matthew. Thank you. So here we've got hydrogen, one of them. Chlorine's going to be our purple. The bell's going to ring, guys. Just keep on going. And with chlorine, we have 17 electrons, so that's 2 in the first shell, 8 in the next, that's 10, and we'll have 7 left. 1, 2, 3, 4, 5, 6, 7. And that's an easy match, right? It's going to move that over here, and it's going to share there. So it's literally just like it shows, H, Cl. Okay? I know I changed colors for you there on hydrogen. And the last one is carbon dioxide. Carbon is our orange, oxygen is our green, oxygen has 8 total, so 2 in its first shell and 6 in its next, and carbon has 6, so 2 in its first shell and 4 in its next. There's 2 oxygens, right? And I'll give you guys an opportunity to see if you can find out how to do this here, okay? Best of luck. See ya!